All right, so here we are with Chapter 8, Section 6. We are going to solve quadratic equations by factoring. So as long as we have kind of a general idea of our previous chapter, then this one should go pretty smoothly. So the main idea here, other than factoring, is understanding the zero product property. So pretty much the idea is that if you have a 0 as your result, it turns out that one of the numbers that you multiplied had to be 0. So if you have some two ideas, A and B, multiplied, and it equals 0, then it turns out A has to be 0 or B has to be 0. And so again, zero product property is just saying that anything times 0 is 0. So, of course, when we're talking about anything, a lot of times we actually talk about, in this case, factors, okay? And so what we're trying to say is, using this zero product property, what would make this term that's then multiplied by this term into 0? So how do we figure out how this equals 0, and how do we figure out how that equals 0? Because if this becomes 0, it doesn't matter what this becomes, because it will be 0 as well. So for instance, what I want to do is figure out when will x minus 7 equal 0. And so going all the way back to our first chapter here, we're just going to solve this to find out what x is. So if we add 7 to both sides, we're going to get an x of 7. So that means that if I plug in a 7 right here, I'm going to get 7 minus 7, which is 0. I'm going to multiply that by 7 plus 2, which is 9. And we're going to double check if that equals 0. Well, this is 0, this is 9. Doesn't matter what it is, because 0 times 9, or anything, is going to be 0. So one of the solutions is x equals 7. Another solution, however, just double checking what color I wrote in there. All right, so the other solution, however, is if we take the next piece, which is x plus 2, and set it equal to 0 and solve. So now we see that if we subtract 2 to both sides, we're going to get an x of negative 2. Plugging that into this equation, we would get negative 2 minus 7 times negative 2 plus 2. Negative 2 minus 7 is negative 9. That's going to be multiplied by 0. And of course, anything times 0 is 0. And so it turns out that x equals negative 2 also works. One quick way of understanding how to get this, of course, is to really just look at your factors, which we have up here, and do the opposites. So your answer is that x could equal 7 or negative 2. Okay. And then the idea is that these, a quick way of solving it, are the opposites of the factors. Okay, so again, negative 7 was here, but 7 was the answer. Positive 2 is here, but negative 2 was the answer. All right. Moving on, if we want to get these factors and use the zero product property, the first thing that you are going to do in these problems is to rewrite the equation so that it's in that format. And we did this in the last lesson as well, but the idea is that it's the standard format of something times x squared plus something times x plus the answer value, the number, and then always equals 0. Okay. Once you rewrite it, we're then going to factor the quadratic equation. So we're going to write it in those parenthesis formats, or if there happens to be kind of a GCF or anything like that out front. And then the last piece is we are going to solve the equation by using zero product property, or that idea of opposites of what's inside of the parentheses. So Taking a look at our first one here, of course, we're not going to do step 1 because it's already rewritten, but we are going to factor. Okay, so if we take the time to factor this piece, we're asking ourselves what multiplies to be 8, but at the same time adds to be -6. So multiples of 8, remembering back to factoring, are 1 and 8, -1 and -8, 2 and 4, -2 and -4, and that's about it. And we are trying to find out which ones add to be -6. And so these are the ones that are going to add to be -6. And so that means that our factoring is going to turn out to be x minus 2, x minus 4. So that is our factoring. But then we want to find out what are the x's going to be. And remember that the x's are opposites. So when x equals 2, which is the opposite of -2, and when x equals 4, those are our solutions. Okay, so the problem with this idea of opposites is that what happens is you end up actually losing the idea of factoring. And so what happens is in this step right here, you start writing this as x plus 2 and x plus 4 because you skip to it being the answers. But you do need to have this step in the middle where you have your factors first as the actual original values here, and then do the opposites to get your solutions. So be very careful that you aren't just automatically doing opposites to find the answers before you even write the factors themselves. All right. So the next one here, we'll use step 1 from the previous explanation. So we are going to take the time to rewrite this so that it equals 0. So this positive 21 is going to be subtracted over. And so now we'll have x squared plus 4x minus 21, and it's going to equal 0. So now we have it rewritten. After that, we're then going to find out what factors work in here. So again, we're trying to find what multiplies to be -21, and then at the same time adds to be +4. So if we look for our multiples of -21, -21 comes from 3 times -7, also -3 times 7, -1 times 21, and then also +1 times -21. So if we work through this, remember that we are trying to find what adds to be +4. And so these two right here are going to add to be +4. And so that means that our factors are x minus 3 from here and x plus 7. And again, those are your factors. Your answers or your solutions from the word solve there are going to be the opposites of each of those numbers. So we can have x equals a +3 from that answer, because +3 inside of here would make a 0, or -7, because again, a -7 inside of that parenthesis will make a 0. All right, so again, solving this quadratic equation is going to be an x of 3 could work, or an x of -7. All right, moving on to the next example here. We're going to solve this one by again asking ourselves what multiplies to be 36. And at the same time, we'll add to be -12. So depending on how good you are with this, again, you may not need to write out each of the factors of 36, but I, again, will take the time to do that just to make sure that we know how it works. So -1 and -36 also multiplies to be positive. We also have 2 and 18, but then -2 and -18. 3 and 12, and -3 and -12. We also have 4 and 9, as well as -4 and -9. And then 6 and 6, as well as -6 and -6. So all of those are the options, and we are trying to find two of them that add to be -12. So these two are the ones that are going to add to be -12. And so in that case, our factors are going to be x minus 6 times x minus 6. Again, that is our factors, but not our answer yet. And so our answer is going to be the opposite of x minus 6. So that means that it's going to be x equals 6. Turns out that we're not going to say both of them because really the only one answer is 6. You can't just say 6 and 6 because that's the same number. All right, so 6 is our solution. All right, then we have an application here as our last example. We have the height in feet of a diver above the water can be modeled by this equation, where t is the time in seconds after the diver jumps off the platform. And we need to find the time it takes for the diver to reach the water. So as we've been doing here, the idea is going to be to factor this and then solve. Because the image here is that we have a diver up on a platform. Little ladder on getting up there, because otherwise how does he get up there? Okay. And so here they are up on the platform, and they are going to dive off and go into the water. And if you do continue this shape, the idea is that it's going to be a parabolic shape. Also, the idea is that they're going to hit the water here, and those are our zeros, or our x-intercepts. Here's the water. Okay. So on that note, again, what we did in the previous lesson was what we're doing in this lesson here is using factoring to find these two numbers, okay, rather than using any other equation of sorts. So in that case, we are going to solve this here to be factored. The first thing, of course, in any factoring is to get out a GCF if there is one, and there definitely is here. I also tend to make this leading coefficient into a positive as often as possible. So in that case, I'm going to divide by -8 to each of these. If you divide by -8, that now means that the height equation is going to be -8 times 2 from this fraction, t squared, and then minus t, or minus 1t, and then over here, minus 1. So we've taken out this 8, okay? And now we have this problem where we have a leading coefficient that is not the number 1. So hopefully you remember back to how to do this. You take the first and the last digit and multiply them, so 2 times -1. And then you're going to find out the factors of -2 that might possibly add to be -1. So the factors of -2 are 1 and -2, and -1 and 2. And we are trying to find which ones add to be -1. So let's see, these ones add and get -1. And so now we know that in our box, we are going to put these two numbers, so 1 and -2, with the variable, which in this case is a t. The other diagonal is going to have the original function, so we've got 2t squared. Technically, in a little circle here would be -1t, noting that that's what these two add to, and then -1. And now we're going to find out what the GCFs of each row and column are. So 2t squared and 1t have a t that is alike. Negative 2t and negative 1 have a negative 1 in both of them. This upper row here has a 2 and a t involved in both of them. And then the bottom row here just has a 1. Remember, especially when working with negatives, we want to double check that each of these does multiply to be what it's supposed to. And so now I know that my two terms, or my two factors, are this top row and this bottom row. So that means that this equation now becomes negative 8 and the factors of t minus 1 and 2t plus 1. So in order to find out when or how long it takes for the diver to reach the water, we are going to solve this equal to 0, because again, we are trying to find out where it hits 0 or this x-axis. So as we set this equal to 0, remember that we are just taking each piece and setting it equal to 0. So t minus 1 equals 0, but then also 2t plus 1 could equal 0. And so in that case, we could solve these, adding a 1 to both sides, and get a time of 1 second. Or we could solve this one by subtracting a 1, dividing by 2, and getting negative 1. Now these are very weird times, especially since this is negative 1 second and this is 1 second, but that is because the person is starting at the peak or the vertex of this quadratic equation. So in that case, this time frame right here is 1 second, but this time frame right here is also 1 second. But of course, he's not climbing up the ladder in 1 second, but if this was a regular thrown object, it would take potentially 1 second to get up here and then 1 second to get back down. And so in that case, we are not, of course, going to say that it's going to take him 2 seconds. No, he starts at the top, and so it's actually only taking the 1 second time to get there. So turns out that it is going to take 1 second to reach the water. Clearly not how it works in real life, but of course we wanted to have nice whole numbers for this problem. So that is your 1 second answer. And of course, you could have just looked at this one here and decided that the opposite of negative 1 was 1. This one is a little bit more tricky, but you can see potentially that you'd subtract a 1 and divide by a 2. And so that's why negative 1/2 is kind of the answer within there. So all right. So this is supposed to be negative 1/2. So how did I get negative 1? So, oh, I did it without, I got ahead of myself. Okay. So this is actually 1/2 of a second up to the point that the person is at, and then 1 second after that. So sorry about that. And so because of that, there's an entire 1.5 seconds of this entire trip going up and back down. And so if he's up here and it's taking 1.5 seconds, 1.5 seconds divided by 2 is going to mean that it's actually 3/4 of a second. So we're going to do 3/4 of a second. Okay. So sorry about that. Apparently I got overzealous and divided by 2 twice here. So you have a distance of 1 second and a half second. And so the distance between them is 1.5 seconds. Divide that in half and you get 3/4 of a second. So either way, from the peak of this parabola all the way down, it's going to take 3/4 of a second to perform that dive.